Unit 10, Lesson 4, Simplifying Radicals and Multiplying Radicals lesson. So that being said, so we're going to try and go through these two concepts here in this lesson, and then the next lesson we'll learn about what we do when we need to add or subtract radicals. So in order to simplify a radical, first off, we need to know what perfect squares are. So this is a list of perfect squares, and again, let's remember what a perfect square is. So for instance, if I take 3 squared, okay, 3 squared equals 9 because 3 times 3 is 9. And then the inverse of that, or kind of going the other direction, is the square root of 9 is 3 because 3 times 3 is 9. So you kind of need to be able to take this both directions. And the better you know these perfect squares, the better you'll be able to simplify radicals as we go through the process. So make sure you take some time to study these so that you've learned them. And then we're going to use our calculator as needed to help us to identify the numbers that we need to use on any given problem. Alright, so first off, what about if we're trying to simplify a square root when it's a perfect square? So the symbol for a square root is this, and it is called a radical. So the sign itself, this little check mark looking deal with the line on the top of it, is called a radical. So radicals are the opposite of exponents. So the same way that 3 times 3 is 9, that means that the square root of 9 is 3. What's the square root of 16? What times itself is 16? Well, 4. What times itself is 49? 7. And so then those become our answers here. What times itself is 100? 10. Okay? All right. So now, of course, most of the time it's not just going to ask us to simplify a perfect square. If we were just simplifying one of these numbers, it would just always be this number, and then we'd be done with it. But that's not going to be the case. So we're asked to simplify, and the number is not a perfect square. Okay, then we have to break it down with perfect squares. So this work's already been pre-done. So if you were to simplify the square root of 80, it would become 4 square root of 5. So let's go through the why. So the reason that we do that is we need to find a perfect square to break down 80. So if you don't know it, then what you want to do is start with what you need, which is 80, divided by, and then you want to divide by the perfect squares that are less than 80. We need to find the biggest perfect square that divides into 80 that gives us a whole number. There's no decimals ever, 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 ever. Okay, so we start with 80, and then what we're going to do is 64 is the biggest perfect square that's less than 80. So technically speaking, you would start dividing there. Now, plenty of you are going to already recognize like that's not going to work. So the more confident you are in your division, you can skip some of these numbers. But then I'm going to work my way from the biggest perfect square down. So now I do 49 decimal. Now I do 36 decimal. 25 decimal 16. Now I get a whole number, and that's the goal. I want a whole number. Remember, whole number just means a positive number with no decimal. So that being said, when I'm looking here, now what I'm going to do is write the 16 and the 5 down. Again, one of these has to be a perfect square. What's the 16? What's the square root of 16? Well, what number times itself is 16? Well, it's 4. So the square root of 16 is 4. So the square root of 16 becomes 4, and the 5 stays on the inside. So we get this answer, which is read as 4 square root of 5, or 4 times the square root of 5. You could say it either way. Okay? Alright, so let's look at another one. So square root of 63. So right away with the 63, I am looking for a perfect square that divides evenly into 63. So I go 63, well the biggest perfect square less than 63 would be 49. As soon as I see I get a decimal here, I delete it, I do the next perfect square, which is 36. Decimal, delete it, 25 decimal, delete it, 16 decimal, delete it, 9. Boom, there we go, 9 times 7. So then what I'm going to do is write 9 times 7. What is the square root of 9? Well, again, that's why it's important to learn these, because the square root of 9 is 3, so then I know it's 3. So the perfect square number goes on the outside, because the square root of 9 just is 3. Square root of 7, that's not a perfect square, I can't break it down, it stays on the inside. So then when we write our answer, we write 3 square root of 7. Okay? Alright, and we never, ever, ever answer in this decimal version. That is not what you're being asked to do when you simplify. Alright, so let's look at another one. The only main difference here is now we have a number out in the front, which is that 2 out there is called a coefficient. So we have 2 square root of 40. So really, the only difference here is the 2 is going to sit on the outside, I'm still going to need to break that 40 down with a perfect square. And then at the very end, any number that comes to the outside would multiply with the 2. Okay? All right, so now before I can do anything else, I need to find something to break down the 40. So I go 40 divided by the biggest perfect square less than 40 is 36. That's not going to help us. 25, not going to help us. 16, not going to help us. 9, not going to help us. And then 4. Boom, there we go. 4 times 10. So we're going to write down our 4 times 10. Okay, now what is the square root of 4? Well, again, the better you know these numbers, the quicker you can do this. So the square root of 4 is 2. Okay, so then the 2 comes outside and the 10 stays inside. Well, now what's 2 times 2? 2 times 2 is 4. So you get 4 square root of 10, and that would be my answer there. Okay, so 4 square root of 10. Okay, so notice the only difference here was when a number went on the outside, it multiplied with what was already on the outside. So that's simplifying radicals. So now let's switch gears and focus on multiplying radicals. And you're going to actually notice, like, wait, hold on. It's one step away from just being the exact same thing we already did. So here it says to multiply the square root of 8 times the square root of 6. All we are going to do when we do this problem is multiply anything on the inside with anything on the inside, and anything on the outside with anything on the outside. If I don't see a number out here, it's like an implied 1. So this is really like 1 times 1, which is just 1, 8 times 6, which is 48. So I'm going to get the square root of 48. Well, what is this? How can I break down the square root of 48? So here we go. 48 divided by 36, decimal, get rid of it. 25, decimal, get rid of it. 16, boom, 16 times 3. 16 times 3. What is the square root of 16? 4 square root of 3. There we go. So I'm just going to type that guy in. 4 square roots of 3. There we are. Okay. All right, let's go to screen 7. So here I'm going to multiply what's on the outside. 4 times what's on the outside. 2. 4 times 2, 8. Then I'm going to multiply what's on the inside. 10 times what's on the inside. 5. 10 times 5, 50. And again, it's the same thing here. The 8 stays on the outside. It's going to multiply with whatever eventually comes to the outside. Okay. And I need to find something to break down 50. Again, as you get better and better in this, you might just start coming up with them off the top of your head, okay? But, of course, I'm just going to show all of them, so that obviously won't work. So then I go 36, decimal, 25. There we go, 25 times 2. So 25 times 2. All right, well, what's the square root of 25? 5, that goes outside, 2 stays inside. What's 8 times 5? 40. Square root of 2, 2 stays inside. 40 square roots of 2. So there we go. 40 square root of 2. Okay, now this one I messed up the computation layer, so I wanted to show you that. I messed it up, but this is the correct answer here. Okay, so what happens lastly when there's a variable? So with a variable, we're basically trying to break that down with sets of 2. So we divide the power out by 2. If there's 1 power left, we leave it inside the square root. So notice this pre-done example, square root of 75x to the third. Well, I'd still break down the 75. I need a perfect square, and the one that works is 25. So you do 25 times 3. What is the square root of 25? It's 5, and then the 3 stays inside. So that's it for the numbers part of it. Now for the variables part of it, I'll switch colors for emphasis. So x to the third, how many sets of 2 can I make out of x to the third? Well, 1 set of 2 with 1 left over. So if I have 1 set of 2, I take 1x on the outside, I have 1 left over, I leave 1 on the inside. So I'm going to get 5x square root of 3x. Okay, so let's show an example that hasn't been pre-done. So you're going to notice here something. I know it says square root of 48x to the fifth. I'm just going to do the 48 to begin, and then I'll go through the rest of it. Now you'll notice the 48, we already did it here. So we're going to do 16 times 3, which becomes 4 root 3, okay? So just to save time, it really was the same one. You know, normally, obviously, you'd need to look these up, but square root of 16, 4, and then the 3 inside. Now notice I did that. I haven't even touched this x to the fifth. So now I'm going to do the x to the fifth. Okay, so here we go. X to the fifth. So how many sets of 2 can I make on x to the 5th? Well, how many times does 2 go into 5, right? It goes in 2 times. So I'm going to take x squared outside because it went in 2 times, and then I have 1 left over, right? Like imagine if I wrote x to the 5th out. Doesn't x to the 5th, think about when we did our exponent unit, doesn't x to the 5th mean x times x times x times x 5 times? How many sets of 2 can you make? 1, 2. So we get x squared outside, 1 left over, x stays inside, and then that's going to be my answer. So I'm writing 4x squared square root of 3x. There we go. All right, and then your practice for these would be to do the screens 10, 11, and 12, which gets you a mixture of, on 10, it's just simplifying. On 11, it's multiplying, but remember that's really just one step away from being simplifying also. And on 12, it's simplifying, but you got the variables in there. And they're all self-checking, so you should already know how you did before you even get going. All right, hope this helps.